Yeah, welcome everyone on the live show and watching the recording afterwards. So, as Anders said, we're going to talk about cloud grill delights, a high-tech approach to perfect barbecue. So, we're going to talk about the three things I really enjoy. That's barbecue, it's IoT, and it's serverless. So, all three in one, perfect combination, I would say. With a short introduction before, who am I? As I said, I'm Jimmy Dahlqvist. I work as head of AWS at Sigma Technology Cloud. We are an advanced service partner with AWS, doing all different kinds of cool solutions. I'm also founder, creator of serverlesshandbook.com, and the place where I collect and store all my serverless things. That's everything from workshops to small architecture patterns, solutions, and everything like that. I'm a AWS community builder, AWS ambassador, and also one of the user group leaders in Sweden, running the user group together with other guys in Scania. So looking at the agenda quickly, I'm going to start with some background and the problem and why this project was born in the first place. Then we're going to do a quick architecture overview to see how it looks and how I designed everything. Then we're going to do a deep dive on the cloud solution, because the cloud solution is what the star of this show is. We're not going to focus too much on the IT parts. So cloud is what we're going to focus on. And then I'm going to do a quick summary, and I'm actually going to talk a bit about the future of this project, where I'm going with it and what I'm doing next. But let's start with the background. Let's start with the problem I was facing and why this project was born. So what I needed, or what I wanted to have a multi-probe thermometer. So I wanted to have like 5 or 6 probes into one thermometer, not having to have like 5, 6 different ones. So I could read the temperature in the smoker, and I wanted to be able to read the temperature in different pieces of meat. Normally, when I do a barbecue session, I normally do more than one piece of meat, probably like 2 or 3 pork butts, maybe 1 or 2 briskets. Do a lot of food to a lot of people. So I really needed a multi-probe thermometer. I wanted to have Wi-Fi connectivity, so I could easily read the temperature from on my phone or on my computer or something like that, anywhere I was. There's a lot of different multi-probe thermometers that you can buy that had Bluetooth connectivity, but not that many that had Wi-Fi connectivity. And the reason for having Wi-Fi connectivity is basically, even if I do a barbecue session over a full Saturday, I still have other things to do. I rarely have the time to be able to sit by the fire the entire day and watch it and things like that. So I wanted to be able to check the temperature anywhere I was in the house. So then Bluetooth is not good enough. I wanted Wi-Fi. I also wanted to have high and low thresholds. Most thermometers only have a high threshold. So when you reach a high threshold, you can get an alert and a warning. But it's really rare you can have a low threshold being broken. So you can get an alert on that. So I really wanted that. And I wanted to be able to detect the temperature trends. If I'm having a quick rise in temperature, or I'm having some slow decrease. And I also wanted to be able to detect things like the stall in the meat. And a bonus would be if I could be able to store all the different sessions. I could maybe watch them later and see, okay, here I did something wrong. The temperature quickly rose, or it dropped, or something like that. So that I wanted to accomplish something like this. So searching the market for a ready-to-go thermometer that can do all of this was basically impossible, or I had to pay a lot of money, which I was not that interested in. So why not build it yourself? We're builders, right? So let's go build. So that's what I decided to do. Why did I need all of this then? Because if you do barbecue and you're familiar with barbecue, you do low and slow, meaning that you have a low temperature over a long time. You want to keep that temperature as even as possible. And the reason for that is you want to tenderize the meat, you want to break down the tissues, you want to render out the fat to create a really delicious piece of food. And I normally say that barbecue is not just cooking, it's an art form. So, but I wanted to improve that art with tech, of course. So that's what I wanted to do. That's why I wanted this. Looking at different smoker types, we have a lot of different smoker types. We have a ceramic one, standard Kamado ones are green big eggs. They're really good, keeping low temperatures low, consume very little fuel, things like that, really good ones. Then you have an ugly drum smoker, also runs off charcoal, pretty good. I have one as well, that one as well. You have electric pellet smokers. You set the temperature and it does everything for you. Basically, it takes away all the art and everything. It's just having in an oven with smoke. So I don't use that. Then you have the classic offset smoker, and that is what I have. I have an offset smoker, and this is my offset smoker. So when buying this one, the store I bought it from actually had in the ads for it, it said, this is the perfect size for a small restaurant or a catering business. So I decided I need that. Of course, I need that. It needs to be huge. So how does an offset smoker work? For you that don't know how an offset smoker works, you build a fire in the firebox here. You have wood as your fuel. You burn wood, so you have a real live fire in the firebox. And then heat and smoke travels up on over the food chamber. So you have the food here in the food chamber, and smoke and heat travels up. And over that flavorizes the meat and cooks the meat. And here we can see my small beta version, 0.1 of my IT probe that I was using during this cook when this picture was taken. So how does it look? This is the IoT device, version 0.1. Basically a breadboard with a lot of cables connected to a Raspberry Pi, and I use standard food probes. And these are 2.5 millimeters thermistor probes, which basically comes with any thermometer. These are actually standard food thermometers from IKEA. So it's actually cheaper just to buy a full thermometer, throw it away, keep the probe, than to try to buy probes that are from anywhere else. So I use that. And if you don't know what a thermistor is a way to calculate temperature from the current resistance. So there are two types. So this is a negative temperature thermistor, which means that resistance decrease in the thermistor with a temperature rise. So when the temperature go up, the current resistance go down. And with that, you can do calibrations. You know that, okay, well, with this much resistance, I know that the temperature is this much, and you can do calibrations. And with knowing how much current you put through it, you can do a calculation on what is the temperature right now. So that's how a thermistor works, very basically descripted. So if we start looking at the architecture overview of how this is built. So we have two main components in this solution. We have the IoT device that is consisting of a Raspberry Pi running Greengrass, and we have the cloud side, it's basically IoT Core, Step Function, Lambda, DynamoDB, API Gateway, and a lot of different things. So, but if we start looking at the IoT device, we have two different parts. We have the hardware part and we have the software part of the IoT device. The hardware is a Raspberry Pi 4 Model B. We have the 2.5 millimeter food probe, so I just show you, and we have I have an MCP 3008 AD converter. So I need to convert the analog readings coming from the thermistors and all of that into digital values. So I have this AD converter to convert it to digital values, so I can do math on that one. On the software side, I'm running IoT Greengrass 2.0. I'm running it as a core device, and I have a custom component built that do all the math and voltage to temperature and all of that. So in the first iteration of the IoT device software, it was actually a Python application. So I built a Python application that fetched all the readings, did all the math, calculated everything that I needed, and transmitted up to the cloud. I updated the device using SSH. I transferred the files from my computer onto the Raspberry Pi, and then had a Raspberry Pi connect directly to IoT Core. Pretty simple. There were some problems, but really hard to do logs. I have to do that over SSH, and updating the software on it was a bit cumbersome over SSH as well. So a couple of few problems on it. And we then look at the cloud side of everything. This is the first solution, how it looked. The happy little man to the left, that's me, I guess, by the smoker. And the IoT device, as I said, connected to IoT Core. And on IoT Core, I used different rules to send information and readings to different locations or different targets. So I sent it to S3, I sent it to DynamoDB, I had some step functions and Lambda functions that had the readings and did some logic on it. The REST API gateway that my simple web app or simple web application connected to fetch the values. I did some notification using SNS over email, actually, to start with. So, but pretty okay solutions, but there was some lesson learned. These lessons learned comes not only from this project, but from a similar project that I actually did with a client. We are not connecting barbecues in that project, but we used some similar mechanics and similar cloud solutions. So one of the first lesson learned was that using IoT Core as the rules router was a bit of a problem. IoT Core is really good at building an event-driven application. But if you do filtering on the MQTT topic on IoT Core, those filters are super easy to manage. You just say, if value comes on this MQTT topic, send it here, and you can do all of that. But if I wanted to do more advanced select, I wanted to do filtering and routing on the actual payload. And yes, you can do that with IoT Core and the rules, but the syntax for it quickly becomes really hard to manage, because you use a SQL-like syntax, and doing all of those selects and all of that if and diff and things like that quickly became hard to manage. So that was one problem, one lesson learned, that maybe this was not that good. It's good on the MQTT topic, but maybe not on the payloads. Second part was that I was storing data directly into S3. What this does is that every event that is coming into IoT Core, that's picked up by the rule and sent to S3, is stored as a single object. There's no buffering. So I get a lot of small objects in S3. So I did temperature readings every 5 seconds. And if you have a 12-hour-long barbecue session, that's a lot of different small objects in S3. And using Glue and Athena to do queries on those, Glue is not really optimized to have a massive amount of small objects in S3. Their performance decreased, and I couldn't do real good indexing on year and time and date and things like that. So that created a big problem for me. It was really hard to change the data format, because if I write data directly to S3 and I write data directly to DynamoDB in this solution, the IoT device actually dictates the data format. So I'm storing it in the data format that is sent from IoT device. And sure, I could do transformation in the rules, but that would be like a nightmare to try to figure that out in a good way. So it ends up that the device dictates the data format. And in my case, maybe that's not a big problem, because I can just update the IoT device and have a new data format. But if you think this in scale, like you have tens and thousands and hundreds of thousands of IoT devices, doing that software update on 100,000 devices just because you want to change the data format and how to store it, then becomes really hard to handle. And the final part, it was actually pretty hard to extend this because adding new rules to IoT Core was a bit of a problem. So it was a bit hard to extend this solution to a new good way to add new services, to add new consumers to the events. So with that, I decided I needed to do some form of improvements. On the IoT side, I wanted to improve the software development lifecycle. I needed a better way to update my software. I also needed a good way to do logs and log handling and reading the logs. Reason for that, figures out that I'm not that good at math and doing all of those probe calibrations and mathematical calculations. There was a lot of problems and errors in that. So some good log handling and reading logs and live debugging was actually needed. I also needed a good way to do configuration changes. What I wanted to be able to accomplish was if I wanted to change the calibration of a probe, meaning that at the current resistant, it means a certain temperature. I needed to be able to calibrate it and change that calibration without having to update a new software bundle. So I wanted it to be able to read calibrations from like S3 or SSM or something like that. So I needed a way to communicate with AWS services. On the cloud side, I wanted to do data transformation. I don't want the IoT device to dictate the data format. Instead, cloud knows about the IoT device format and then transforms it into a cloud format that can be used inside the cloud solution. I wanted to move to a different event-driven architecture. I wanted to use event-driven architectures to be able to decouple the services. And even if IoT Core can be used to build event-driven architecture, it's good at it, I wanted to have something that had an easier way to create new rules. So if you start looking at the IoT device and the changes, what I did to move this to the next level is that AWS Greengrass, it comes with a lot of the things that I actually needed. It has the possibility to interact with AWS services and makes it easy to interact with AWS services running in the cloud. Because in IoT Core, you have the permissions endpoint, meaning that what you use the X509 certificate that you have on your IoT device, you use that, exchange that for temporary AWS credentials, IAM credentials that you then can use to communicate with S3, DynamoDB, and so on, whatever you want. Sounds familiar? Yeah, that's IAM roles anywhere, because that's exactly how IAM roles anywhere works, but it came for IoT to start with. So it feels like something that has been brought out of IoT and made into a standalone service. AWS also have components for Greengrass, like a log manager. So it reads the logs off the device and posts them to CloudWatch. Perfect, that's what I needed. And then you can build your own custom components. So you can create your software as a component, and then you can push new versions from cloud onto the device and update the device remotely, which was exactly what I needed. And I could sit in cloud, do all my testing and debugging, and then just create a new software bundle and then push it down to the device using Greengrass. Greengrass also has support for running Lambda functions. So I was experimenting a bit and turning the logic into a Lambda function instead of having a long-running solution that I had at this point in time. So if we move over to cloud and the cloud architecture, because this is the star of the show, and this is what we're going to focus and talk the most about, this is how it all transformed. So the happy little man to the left, still me, and the IoT device still connects to IoT Core. But gone is all of the different rules in IoT Core. Instead, there's one single rule that picks up all of the messages and posts it onto an SQS queue. Connected to the SQS queue, I have a Lambda function that picks up the readings and posts that onto EventBridge bus that then can send the data to different services. First of all, it will send data to an augmentation service, but it can also send all the data to notification, detection, data, and a lot of different services. Now, I have an easy way to create new rules and extend this in a good way. So if you look at that part, in the ingress part, if you start looking at the ingress part, using IoT Core together with SQS actually creates one of my absolute favorite architecture patterns, the storage first patterns. So this way I could reliably capture all the data. I could, of course, connect the Lambda function directly to IoT Core and then just post it onto EventBridge. But I decided to have it land in SQS queue instead, because if I have a problem with my Lambda function, I can just redo the data processing and without losing any data. The best solution here would, of course, to have a IoT Core directly to EventBridge, but that integration doesn't exist. It's not possible to do that at this moment, unfortunately. But that had been the best solution for this part right now. One small thing to talk about, of course, is this Lambda function here. I'm going to talk a bit about it later down the presentation, but maybe this is not the optimal solution to have a Lambda function here that just do transportation of data. But I decided to use that with SQS as there is no direct EventBridge integration. If you then take a look at this service down here, the data augmentation service, this is something I built because I wanted to add more data onto each event. I wanted to add like 3 or 4 of the previous readings. That means I had 4 or 5 readings, the current one and some past ones in the same event. That way I could do easy detection of thresholds, for example. I also in this one added an event envelope, so I could have versioning of the data and things like that. So I used the envelope pattern to extend and have versioning of all of the events. And I did transformation. All of the data transformation is done in this service. So I transform it into the format cloud then needed on a cloud solution where services needed or OSPO instead of having the IoT device detect that one. So this one is the transformer of the data. So looking at it, it's pretty simple. We get the thresholds from DynamoDB, doing some get items, getting some readings, previous readings, stores it back. Have a Lambda function that does the data transformation, adding an envelope, things like that, and then post it back to EventBridge. It does a bit more than this, but in the nutshell, this is what this augmentation service does. Continuing here in the cloud architecture, this new service, the detection service here, is actually one of the star services. This is where all the magic happens, so to say. Well, this is where all the barbecue magic happens. Once again, it's a step function. And this is where I do threshold breach detections. I do temperature trends, and I detect the dreadful stall. And looking at this, I use the technique. I have a step function, and I invoke sub-step functions from it. So I have a step function that just do trend analyze. I have a step function that just do detection of the stall. And then I have a lambda function that just do notifications and things like that. So when we talk barbecue, if you don't know what the stall is something that happens around 70 degrees Celsius, around 160 degrees Fahrenheit. And what happens is that temperature in the meat suddenly just stops. It stops rising. It just stops. It just stands still. It stalls. And sometimes it actually drops. So I did a barbecue this weekend to prepare for this session today. And hitting 68 degrees Celsius, my temperature in my pork butt just stopped. And it went down 5 degrees Celsius. So it went down to like 62, 63 degrees Celsius. And it stood there and it was still. And the reason this happens, there's as many theories why this happens as are pitmasters, but the two I most believe is One, the fat start to renders, which means that the meat cools down. And the second is that the meat acts like our skin, so it actually starts to sweat and cools everything down. So I probably think it's the fat that starts to render out and cools down the meat. And what you need to do in this situation is just power through. That's not much you can do. You can wrap maybe in a butcher's paper or something like that, but otherwise it's just power through. But I wanted to know early when this happened, so building a detection service for that was really good. The last part is the entire thing. As I said, I wanted to have something that was event-driven, easy to extend. And this is exactly what I got. Using EventBridge and EventBridge Bus and all the rules, it's easy to create new targets. It's easy to add new rules. It's the language or the queries you write for the targets are really easy to handle and makes everything very easy to extend and good to extend. So it made a perfect solution for me. As I said, serverless and event-driven, the benefits of it, everything is loosely coupled. All of the services can scale and fail independently. Because if my notification service fails, I don't want my service that serves data to my app to stop working and things like that. It's also super cost efficient. When I don't use it, I don't run it, I don't pay anything for it. Good extensibility. And of course, it comes with highly availability out of the box, since most of AWS serverless and event-driven services does. Now, the main question here, has all the tech helped me create great barbecue? Well, I let the results speak for itself, and I would say yes, it has. I've done burnt ends, ribs, pork butts, briskets, you name it. Yes, it made a lot of difference. It made it easy to keep an even temperature. I detected early when, oh, you might need to add more wood to the fire and things like that. So yes, it definitely increased my barbecue skills. Some takeaways and thoughts to leave you all with. Choreography orchestration that I use together makes a perfect combination. I can have the business events flowing into EventBridge and just flow out to all the services as they need it and what they need to handle. And then if I have unique business logic that need to be handled in a different order, in a specific way, then I can use step functions for that. So the combination of choreography plus orchestration is match made in heaven, I would say. I was using a lot of step functions, and I'm still using a lot of step functions. That's my go-to service. I use it for most of my compute nowadays. That's good to understand that the two different workflows you have. You have the standard workflow that is more for long-running tasks. It can run up for 1 year. You have 2,000 starts per second, which is basically enough for everyone, but you pay per state transition. So if you have 100 states, you pay per each state transition. If you have 2 states, you pay for each of those. And then you have the express workflow for your short-running solutions, 5 minutes or less, 100K starts per second, and you pay for the duration, like a Lambda function, for how long it runs. And you can do combinations. You can have a standard workflow, and then from that one, call an express workflow to do sub compute or something like that, and then return. So combining these two can create a really powerful way of creating a step function workflow. What you should remember is that express workflows employ an at least once model for asynchronous invocations, meaning that you can get the same event twice. So you need to design for idempotency, so you'll be able to handle that you get the data twice. In my small solution, that rarely happens, but as I said, working with a different IoT client where we had hundreds of thousands of devices running express workflows, then on the data coming in, it actually happens quite a few times that we got more than one invocation on the same event. So remember it and design for it. When building event-driven applications, create subscriptions. Each rule in EventBridge can have up to 5 targets. Don't do that. You would create a coupling on the filter itself, and it's really complex to add more targets, because if you have 5, then you need to have a new rule with the same filter. But if you remove one rule, how should you move that? Or one target, how should you move that around? So, and changing the filter actually affects all of the targets. So if you want one of the targets to have a different filter, then you have to break it out. So instead, I always use a one-to-one mapping. So one rule, one target. That way you create a coupling on the event. And it's easy to extend, it's easy to add more targets, and filters can change 100% independently. You could have a rule explosion, of course. You have a massive amount of EventBridge rules, but I take that any day over the problem with having a coupling on the filter and not on the event itself. When using EventBridge, there is a default EventBridge bus in each region. Leave it alone. It's for the AWS services. They use that one to post events. It's EC2 events when instances start, and events like that when you have a new object in S3, etc. So leave it to the AWS services. Create your own EventBridge buses for your application to use. That way you don't leak business logic, and it's the same rule. That's why we don't use default VPC. Leave the default bus alone. The last, one of the last points here, Lambda functions. I would normally say use Lambda to transform data, not to transport data. So actually having a Lambda function here, that's the only job it does is move data from SQS to EventBridge. Probably not the most optimal use of Lambda functions. Instead, I could be using something like this, using EventBridge pipes to move the data from SQS to EventBridge. Works okay. I haven't played around enough with it to give it a perfect verdict, but if you don't have any other choice than to use the Lambda function, of course, you have to use a Lambda function. But if you can avoid it, do it. Use Lambda to transform, not transport, let's say. So what's in the future for this small project, and what's the summary? First of all, I have removed my own hardware. So I'm not using all my own food probes anymore. I'm not doing any math. Instead, I have an Inkbird IBT6XS, which is a Bluetooth thermometer with 6 probes. I still have my Raspberry Pi. So I connect to the Inkbird from my Raspberry Pi, and I read data values from the Inkbird over Bluetooth Low Energy to the Raspberry Pi, and I send that to the cloud. That way I get rid of all the weird problems I had with probe calibrations and stuff like that. Often these thermometers has their own proprietary protocol, but it could be reverse engineered, and there are some smart people on the internet that has reverse engineered the protocol for exactly this one, which made it easy to use. I've decided to make it a SaaS, not as something that maybe go commercial. Just make it a SaaS solution with user management, tenant isolation, things like that, because it's fun to build a SaaS solution serverless with IoT. My plan is, or I have already started working on a series of blog posts, and that will be open source of everything, and I will release it on serverlesshandbook.com over like the coming weeks and months. So if you want to keep track of that, follow me there. Other things that would be fun to do, add a camera support. That way I could have a camera pointed at the fire and do even earlier detection of when the fire is starting to die out, because my offset smoker is 6mm iron, so it's really thick. It retains heat really good. which means it still takes some time for my probes to detect when temperature starts to drop. So having a camera maybe on the fire, I could detect things even earlier. I do a super simple detection today. Maybe train an ML model for it. AI is the latest trend, right? So do some ML to do detection in a different way. Do some echo integrations. So maybe I could use my echoes all over the house to check what the temperature is and have notifications sent to those. So if you're going to summarize a bit what I've been talking about for the last 35 minutes, we looked a bit on how to building an IoT system, different devices, IoT green gas, IoT core, looked how to build a serverless and event-driven solution, and we looked at how to get some great barbecue with the help of tech and technology. So thank you all for listening.
Stuff. You definitely made me hungry. It's about lunchtime for me. But
Yeah.
that looks very cool.
Thank you.
So question on the camera side, are there actual cameras that support high temperatures that you could put inside the grill?
No, no, I can't put it inside. I have to put it outside and have the on the firebox there is a small. I can open it up on the side, so I can have the camera outside.
Oh, okay.
No, it would not. It would burn up.
Yeah, that's why it's yeah. It's like,
Yeah.
do they exist? That would be nice if you can just have one point into the
That would be
bread. You don't
yeah.
have to open the grill, right? You can just point it inside and
no, that would be awesome. So it would be looking in. Yeah.
Would it be complicated to get like yours is very manual, right? You like the offset one that you have to burn the wood manually, but if you had one like a lazy me that I would use a pellet smoker to get that feedback loop to turn it down or turn it up.
Yeah. You could actually, there is projects doing that. If we're looking at through the open source communities, where they have green big eggs, for example, the Kamado grills. So what they do is they place the fan on the air intake, so that when the temperature starts to drop too much, they start the fan to build more draft and they're rising the temperature. So you could be doing things like that, definitely.
Nice, that's awesome.
If I could have a firewood feeder or something like that going into the smoker, that would be next level.
Just something chopping the wood and put it in
the.
Would be interested if you get to that.
Yeah, probably not.
Yeah, if I feel like a Weber or a Traeger or something is going to steal you, you're probably going to get interviews tomorrow. It's very interesting use of tech.
Yeah, definitely.
Yeah. So I shared recently, and I did a brisket. It's actually the second time. The first time I failed miserably, but both times the stall got me. It's stressful. I invited people to eat, and it's like, oh, it's almost ready, but not really. It's just stuck there.
And nothing happens. And you suddenly see the temperature going down. You go, what now?
Yeah. Is one burner out? I don't know what's happening. But the question here is actually how do you detect the stall, right? Is it just based on standstill on the temperature?
Yes. It's based on standstill, and if it starts to drop more than below a certain point. So if I have a reading of like 65 degrees Celsius and suddenly it's 64, then 63, then I know, okay, I hit the stall. Otherwise, it's just a standstill over a period of time because normally it rises a bit. I have a curve that's normally happening. So it's, that's what I wanted to do with ML maybe later to have. Now it's just value, looking at the previous values and things like that.
Yeah, looking a bit at the history. What's the time interval per like temperature check that you're getting?
I read every 5 seconds.
Okay, yeah, so you would get a pretty.
I do get a present resolution on it, yes.
Yeah, I have one of those the meter probe, and I love seeing the graph, right? So you can really see it slow down. It's like, okay, So the visual of the data, you can really get some great
You can get
some
really
great
nerdy in
graphs.
that as well.
So do people over there call it the when you wrap it in the butcher paper and all
Yeah.
that, if you want to take the easy way out of the stall, do they call it the Texas crutch over there? Because I know they call it that
Yeah,
here.
no, they don't. Not,
Is it
no,
just wrap it, just wrapping
yeah,
it?
wrapping it. Yeah, that's wrap.
You should make it the Texas crutch in,
Yeah,
over there.
I should do that. Definitely.
David, Danielle, any questions y'all have? Are you hungry too?
I
I was
actually,
gonna ask, what's the pricing on this? Does it fall in the free tier pretty easily?
oh yes, yeah, definitely. It's if I, yeah, it's never going past free tier so far.
Yeah, I've never done IoT, so I don't know the pricing and what the free tier levels
And
are for
you can send a
Greengrass.
lot. You can send a lot of information on using Greencast is basically just a component running on the device, so that you start communicating with over MQTT. So it basically messages are going back and forth. So yeah, you can keep
That's
it
cool.
free tier. So yeah, I actually did this session in a different conference once, and I had the session right before lunch.
Yeah, I'm struggling. But yeah, that's cool that as far as the cloud services, it ends up on the free tier. And as far as like the physical, like the breadboard board and the um, Raspberry Pi and all that, what does that run you?
Uh, Purchased everything. I think I paid in total $50, something like that, for everything. So it's an okay way to price it. Yes.
Yeah, it's you got to get the hardware. I mean, and if you go to IKEA and get the cheaper pros.
Yeah, you can buy the more expensive probes, and then you normally get the calibration sheet and all of that. But those a single probe can run you at least like $50-$60 just for one single probe. So then if you want to have three probes, it's like, no, I buy a $10 thermometer from IKEA and I try to do the calibration on my own.
Yeah, use that money for more premium beef, right?
Yeah, exactly.
Cool. And how are you? What's your combination of the standard and express workflows, right? It's like I've personally used it, like you said, I have a standard workflow, ingesting data or something, and then with like a distributed map or something, just trigger a blast of express workflows,
Yeah.
just to make it faster. And so,
Yeah,
what's
exactly.
your
In this project, I primarily use Express because I don't really need a standard workflow. But in other projects that I'm working on with clients, we do exactly what you're saying. We have a standard workflow, and that is what is driving everything. And then it calls into Express workflows to do distributed maps. So we have a lot of data coming into S3, for example, and we do a distributed map on that to do calculations. And then we do that part in Express. Then we have a standard that just coordinate everything for us. So, but in this project, I just use Express all the way.
cool? Makes sense. It's a lot of small operations and stuff like that.
Yeah,
So
it is. It's there. Yeah,
goes quick.
So pay for runtime instead of state transitions, because using standard workflows can quickly become very expensive, I think, especially if you have have high velocity IoT data, for example. You send a lot, hundreds of thousands of devices sending data, then those state transitions will kill you in the pricing. So, and it's Express all the way.
Yeah, getting it more into the Lambda pricing, right? Just per time.
Exactly.
Cool. And it scales a lot faster, right?
Yeah,
The Express one?
Yeah, it does. It does. You basically have unlimited scaling, I would say, on the Express one.
Nice.
Mm.
Cool.
Mm.
Any other questions?
Or people are
I
hungry,
guess.
they want to go eat or something.
Yeah, it's like now I'm gonna go cook. I'll just hit Rudy's here in the corner. Get some barbecue. I don't have time right now to
No,
cook a full
exactly.
brisket.
You're gonna have a nice salad for lunch after all that.
After all the meat talk, you need a nice.
Yeah.
Cool. Well, thanks a lot, Jimmy. This was truly a great talk. It's a great, incredible use of technology, feeding kind of your own hobby, one that I've started to get into. So I can't wait for the SaaS, the open source version of this, so I can try it out and start playing around with it.
Absolutely. So no, it was nice. Thank you for having me. It was very, very nice being here.
Awesome. Cool. I will do our announcement. Well, it's not an announcement, but tomorrow Ben and I will be doing live stream when I've been doing weekly. So we're going to be live coding and trying out AppSync. Neither of us have used AppSync and GraphQL, so
Cool.
we'll see what happens. We'll see how far we get. We're trying to build a pizza ordering system for the Teenage Mutant Ninja Turtle. So we'll see how we we can get that rolling. Yeah.
That's perfect.
Awesome. Well, thanks a lot, everybody, for joining.
Thank you. Have a
Thank
good
See you
day.
you.
later.
Yeah.